Bismillahirrahmanirrahim. Okay, guys, let's start the differentiation of P3. Uh, when I'm going to start this differentiation of P3, so I just want to make sure that you know that what is d by dx of x raised to power n. That is the first rule of differentiation that you have learned in your P1. Okay, that is nx raised to power n minus 1. Okay, and then there is a second rule, which is the d by dx, the power rule, basically, where you have the power on an expression. Okay, so this is going to be n into ax plus b raised to power n minus 1 times a. For example, if you have, let's say, y is equal to, there is x cube plus 5 under root x plus 2 over x square plus 5. So you must know that what will be your dy by dx. So this should be using the first rule of differentiation. This should be dy by dx, that is 3x squared plus 5 over 2 under root x. And before you differentiate this 2 over x square, you must write it as 2x is per minus 2. Okay, so this would become minus 4x is per minus 3. Okay, and then the derivative of 5 is going to be 0. Similarly, if you have y is equal to, let's say, 2 over, let's say this is simply x plus 1. So we cannot differentiate the denominators, I mean the expressions in the denominators. So you have to write it as 2 into x plus 1 raised to power minus 1. And now you can differentiate it as, this is minus 2 into x plus 1 raised to power minus 2 times 1. Okay, so then you write it as minus 2 over x plus 1 whole square. Okay. uh, okay, there can be something like this as well. Y is equal to, let's say, uh, 5 over x square plus 1, and there is a square on it. Okay, so this has to be written as 5 into x square plus 1 to the power minus 2 before you differentiate it. And now this would become dy by dx is minus 10 into x square plus 1 raised to power minus 3, and then you have 2x with this. Okay, so this is going to be minus 20x over x square plus 1 whole cube. So this is all your P1 differentiation, where you only have these two rules. Okay, one is for the differentiation of polynomials without any powers, and then you have these are for the polynomials or any other like algebraic expressions that are in this form, like all terms, they are separated from the other terms. There is no product happening, there is no quotient, no division kind of a thing happening. Okay, now when we move from the P1 differentiation to the P3 differentiation, so then we have the questions like, if you see this here in this exercise, look at these questions here. You have the products over here, like x into x minus 2 raised to power 5, or this is 5x into 2x plus 1 to the whole cube. There is this in this E part, x cube into the square root of 2x minus 1. Now, these are the products that we do not like to expand, or we don't have the skills to expand such expressions. Because normally, if you have, for example, suppose if you have y is equal to x square into x plus 1. So yes, we know that before we differentiate this, we can write it as x cube plus x square, and then we can differentiate it. But if you look at these questions over here, we cannot, like, uh, the maths we have learned so far, through that we cannot expand these expressions. Okay, so we have to learn a technique where we can differentiate without expanding. Okay, so for that purpose, you will have to wait. Okay, so the rule that will help us to differentiate these products is called the U dot V, or the product rule. Okay, so if you have to differentiate a product, which is U dot V, where U and V, they are both functions in X, then this would be uv dash plus vu dash. Okay, where u dash means the derivative of u and v dash means the derivative of v. Okay, now suppose I'm going to do that first part here, which is y is equal to x into x minus 2 to the power 5. So you will have to say, okay, my u is x and my v is going to be x minus 2 raised to power 5. If you want to learn this new technique, you must be very good at the first two techniques of differentiations. Okay, differentiation. So u dash, you must know that what is the derivative of x, which is going to be 1, and then v dash, that is going to be 5 into x minus 2 raised to power 4 times 1. So this is simply going to be 5 into x minus 2 raised to power 4. Now it's a time to write this dy by dx. So if your y was u dot v, then your dy by dx, you must write this formula time and again every time you differentiate, so that you learn this by heart. Okay, so this is dy by dx. So u is x and v dash is 5 into x minus 2 raised to power 4, plus v is x minus 2 raised to power 5 times 1. That is your u dash. Now, when you go further up into these techniques of differentiation, the where your differentiation becomes more and more complicated, there you need to be better at your algebra as well, because more and more algebra is going to be involved here. You see that the differentiation is done here, but you have to factorize this. What is common in these two expressions here? If I write it as 5x into x minus 2 raised to the power 4, and this is x minus 2 raised to the power 5. So what is common here? Hmm?
x minus 2 raised to power 4.
X
Yeah,
minus 2 power 4.
yeah, this is going to be common here. Okay, you have to take common. So then you have 5x and then plus x minus 2 left here. Okay, so this is going to be x minus 2 raised to power 4 into 6x minus 2. That can further be written as equal to 2 into x minus 2 is for 4 into 3x minus 1. Okay, let me do one more question for you, and then you can start practicing it once you get to know, okay, what is this technique about. Okay, now let's try the e part. Okay, in this E part, we have maybe this color would look better here. Okay, now this is going to be y is equal to, this is x cube times the square root of 2x minus 1. Okay, so clearly it's a product. Okay, so you should say my u is x cube and my v is the square root of 2x minus 1. We must be very good at this differentiation of the square root thing that you have done in your
1 over
P1.
2
Okay,
under root
yeah,
x.
this is 1 over
3x square.
2, 1 over 2 under root
2x
this
minus 1
2x minus 1
over 2.
times this 2. You must learn this by heart. This, Walid, are you familiar with this method, beta? Hmm?
Yes, sir.
Okay, so u cube is going to be 3x square, and your v dash, u dash is 3x square, v dash is 1 over under root 2x minus 1. So the time to put that into this dy by dx, which is uv dash plus vu dash. Okay, so u is x cube and this is our v dash 1 over the square root of 2x minus 1 plus, then your v is under root 2x minus
U
1
dash is equal to 3x square.
times
3x
3x
square.
square. Okay, so here you will have to take the LCM first of all. Okay, so the LCM is going to be 2x minus 1. So we have x cube here, and then
2x minus 1.
3x cube, oh, so this is 3x square, okay.
Yeah,
3x square
into
into
2x
2x
minus 1.
minus 1.
Yes.
Because when you multiply this under root 2x
So
minus 1 with the
the
under root 2x
powers
minus
will
1,
add up.
so this is going to be under root 2x minus 1 times under root 2x minus 1. So that will be 2x minus 1, okay.
Yes.
And again, you can take x square common from here, है ना? So this will, just a minute, this will now become, I'm going to do it here, the remaining part, okay? So this dy by dx is going to be, um, this is going to be, if I take x square common from here, so this is x plus 3 into 2x minus 1 whole over under root 2x minus 1. And finally, this is x square into x plus 6x is 7x minus 3 whole over under root 2x minus 1. So would you like to try the questions now, or should I keep on like showing these differentiations? Do you want to try these questions now before A?
Sir, could you do one more?
Okay,
For H maybe.
okay, H. Okay, okay. Let's do this H part. Fine. No problem. No problem with that. I'll be using some darker colors now. Let's keep it all blue and black. Okay, I love these colors basically. Okay, so on this we can use white easily, or maybe yellow. Okay, this H part. Now this H part is, let's write this as y is equal to 2x minus 1 raised to power 5. And then you have 3x plus 4 raised to power 4. So we should say, we should start by saying that my u is 2x minus 1 raised to power 5. And my v is 3x plus 4 raised to power 4. Now this u dash is going to be 5 into 2x minus 1 raised to power 4 times 2, okay? And then this v dash would be 4 into 3x plus 4 raised to power 3 times 3,
Yes.
okay? So we simplify them a bit. So this is going to be, um, this will be uh, 10 into 2x minus 1 is per 4. And this one would be 12 into 3x plus 4 cube. Okay. So your dy by dx, which is going to be uv dash plus vu dash. Okay. So that would now be this dy by dx. So u is 2x minus 1 raised to power 5, and v dash, I can write 12 of v dash here, okay? 12 into 3x plus 4 whole cube. And then plus I mean u dash is 10 into 10 into 2x minus 1 is for 4 into v is 3x plus 4 raised to power 4. Yes, Bacho? And you see now you'll have to show your algebraic muscles here. Okay. So what is common in them?
3x plus 4 raised to power 3.
And
2x minus 1 raised to power 4.
2 as well,
Oh.
because you have 12
Yes,
here
yes.
and you have 10 here. So your common is going to be 2 into
2x.
2x minus 1 raised to power 4 into 3x plus 4 raised to power 3. Okay, and we are left with 6 into
This
2x
6
minus
into
1, yes,
yes, and
and
3x plus 4.
5 into plus 5
Yes,
into,
3x plus 4 raised to power 1.
yeah, this is 3x plus 4. Okay, and then this is going to be 2 into 2x minus 1 raised to power 4. So Walid, you can see that beta there is a lot of algebraic simplification required here. है ना? So this is 12x plus 15x is going to be 27x minus 6 plus 20 is going to be plus 14. So this is the final answer for this H part. Okay? So you should try these questions, the parts from the first question, okay, and then you can go on to the application. So your first task is to practice all parts of this first question, okay, like this. So you try all of them, and then maybe in our next class we can go on to the quotient rule, and then we shall be going on to the applications. Okay.